This is the last video of the series where we're doing a walkthrough of the functions that we added to the linked list ADT, either in the ordered or unordered linked lists, or just in the linked list h.h file itself. So this is the last of those and probably the trickiest. And this is the divide mid. So the divide mid, it's not going to matter whether it's unordered or ordered. So we can just go ahead and place the function directly in the linked list.h. So that simplifies our lives a little bit. So this takes, as you can see on the screen here, a parameter of another linked list type. Okay. So it's going to take that sublist. It's then going to divide the original list up into two pieces. The first half of the original list stays the same. The second half of the original list is going to move to the sublist in the same order as it was. Okay. So that's why this one gets a little bit tricky. Uh, so we're going to go down to where I've got the function signature started here and divide mid. Okay. So right here. Okay. So for this one, our first thing here, we want to make sure that the other list is actually empty. Okay. So we're going to do a story list. If we don't do this, then whatever's left over in that list will stay there. And when we add the other stuff to it, we'll get an incorrect answer. Okay. So we're going to go ahead and get rid of that. Make sure it's cleared out. Okay. So the next step, we have to determine the midpoint. Now, you could just take the length, which we have. The ADT keeps track of length for us. We can just divide that by 2, and that will work. The problem is, if we have 10, we divide 10 by 2, we get 5. That's 5 in each. That's fine. But if we were to have 9, 9 divided by 2 is going to be 4. Okay. That gives us 4 in the original list and 5 in the other list. And that feels wrong to me. It's not wrong. I'm not going to count off for it. But for that reason, I like if there's an extra item, I want it to go in the original list, not in the other list. Okay. So I have to complicate things a little bit. So I'm going to initialize my integer mid that I'm going to use to keep this value. I'm then going to say if length mod 2, and to be consistent, I should put this there, but I know in this case it's not going to matter. If it would say something like length not found, then I would know I need to put this in there. Okay. So if the mod of 2 equals 0, we know it's even. And then I can just set mid be equal to the length function divided by 2. Okay, that's all I have to do there. Okay, I have my else. It's not even, must be odd. So I would then set mid equal to the length divided by 2 plus 1. Okay, to keep that middle value in the first list, not in the second list. So in that case, a 10 would return a mid of 5, but so would a 9, which would give me a 5 in the original list and 4 in the other, which is what I want. Okay. So from that, I can figure out then how many items I'm going to need to remove. Okay. So I have so many items um, that we need to deal with. Okay. And I want to figure out what that number is. So in the example of if we have 10 items and our mid is 5, then I need to remove from the original list 5 items. Okay, so I'm going to get that number to remove. So I'm going to say int num to remove. It's going to be equal to the length that we have minus that midpoint. Okay. Again, the example of 10, I would have 5. Okay. So I'm going to go ahead and put an example in here just so we can kind of play with it a little bit. I think it'll help to visualize what we're doing. So let's say our original list has the following: 2, 3, 4, 5, 6. Okay. In this case, the length at this point is going to equal to 6. There's 6 items there. Our mid would be equal to 3. Okay. And our number to remove from our first list would be equal to the length minus the the mid, okay, or 6 minus 3, or 3. Okay, so I have 3 that I need to remove. Okay, so if we have here, so this is my original list. Okay, and below it, I'm going to put my other list. It currently has nothing there. Okay, so I've got to figure out how I'm going to move those values. Okay, so in this case, I need to move the 4 and the 5 and the 6. Okay, so I don't have any way to get to the 4, the 5 without starting at the beginning and going through. Okay, but there is a front that points to the 1, and there's a back that points to the 6. Okay, so I can use this fact that back points to 6 to go ahead and add the 6 to my other list. Okay, so if I were to do that, okay, I would add. So let's take a look at the code here. So we'll do these two things simultaneously. Okay. I'm going to say other list dot insert. I'm going to do an insert front. We'll talk about why in a minute. And what am I going to insert? I'm going to insert what is at back. Okay. We may want to say we don't have to, but if I can say this back. Okay. So this back is equal to 6 right now. I want to insert that to the front of my other list. Okay. So when I do that, the 6 appears here as well. Okay. And then in order for this to work out, I now have to get rid of that 6. But since I know the value of it is back, I can do that. So I can say this delete node back. Okay. That's going to delete that off of there. Okay. If I would do that again and insert to the front the 5, this is why it has to be insert front. If I did a regular insert, the 5 would be there. It'd be the wrong order. Okay. But since I did an insert front, it's going to insert the front there. There's the 5. It's then going to delete it. Okay. That one more time, we're done. I'm going to do it 3 times. Okay. 3 times is our number to remove. So all I have to do here is put this in a while loop. Let's say, not a while loop, a for loop. For int c equals 0, as long as c is less than the number to remove. That's going to give me a 0, 1, and a 2, which is what we want. C++. Okay. I'm going to do that line, going to do that line. Okay. That should do it. That should work. Now, of course, in this function, we'd want to actually print it out to make sure that it works, but that's going to be the meat of that dividing into mid. Okay. And you now have those 2 functions. So in the test program, you have to have the original list or the original linked list. You'd have to have another linked list that you would send as a parameter in this function. You could then, from the test program, print both of those out. You wouldn't want to print it out in this function. Okay. So that's the divide mid. Okay. So delete the other list, find out what our mid is, whether we have an even or an odd length, figure out how many we're going to remove. That was just my simple example I'll get rid of here. We're going to go through and loop through, and we're going to, every time through, we're going to insert the back of the original list onto the other list, to the front of the other list. Okay. We're then going to delete that node from the back. Okay. And that should do it. So those are the 3 programs. Even if there's no credit available any longer for them, it's probably worth your while in typing these in and making sure that they work properly. When we get to the abstract data types for bunches of things, for stacks, for queues, for heaps, working with these ADTs are good skills to have. Okay, so it's important that we understand these skills. So that's why I took the time to create these particular videos. Okay. If you're still struggling with any of this, then make sure you ask questions. You can text me, or you can ask something in class.